On the Shima Peninsula of my Prefecture, in the coastal villages surrounding the city of Toba, there is a tradition that is approximately 2,000 years old. Women, called ama, which translates from Japanese as sea women, dive into the Pacific Ocean without wetsuits, without oxygen tanks, and without any equipment that would insulate them from the temperature of the water. They hold a single breath and descend to depths of 5 to 30 meters, foraging for abalone, sea urchin, turban shells, and the brown seaweed that has sustained these communities across 100 generations. They surface, exhale through a specific controlled whistle called the isobue, breathe, and dive again, for hours at a time, across a working life that, in the oldest documented cases, extends into a woman's 80s. There are approximately 2,000 active ama divers remaining in Japan today. The tradition is recognized by UNESCO, and visiting physicians and anthropologists who have documented these communities since the earliest written accounts in the 8th century have consistently noted something that the aesthetic medicine industry has never once commercialized, because it cannot be isolated into a vial or extracted into a cream. The cervical skin of the older ama divers, the skin of the neck from the jawline to the clavicle, does not follow the trajectory that identical age groups and non-diving populations show. The crepey texture, the platysmal banding, the loose submental skin, and the visible cervical laxity that Western medicine calls turkey neck is largely absent in women who have maintained the ama practice across their adult lives. Their necks age differently. And when you understand what the diving practice has been doing to the connective tissue of the cervical dermis across 50 years of repetition, you understand why. Welcome to Dr. Mylan Health. Subscribe and hit the bell. Our complete anti-aging book covers every cultural, environmental, and biological mechanism that determines how the face and neck age, organized by what the research actually shows rather than what the product industry finds convenient to promote. The link is in the description and in the comments. Now let me show you what 2,000 years of Japanese sea diving has discovered about the cervical skin that the aesthetic industry has spent decades trying to replicate at $3,000 per procedure. The first mechanism is cold. Not cold in the ambient sense that most people experience in winter, not the mild cool of an air-conditioned room or the chill of an October morning. Cold in the physiological sense. The ama divers of Toba work in water temperatures that range from approximately 10 degrees Celsius in winter to 27 degrees in summer. In colder months, the temperature differential between the diver's body temperature and the water surrounding her is severe enough to trigger responses in the cellular biology of her skin that do not occur under ambient temperature variation. Inside the dermal fibroblasts and epidermal keratinocytes of the cervical skin, the skin most exposed during the diving position, the acute temperature drop activates a family of proteins that most people have never heard of and that the skincare industry has not found a way to bottle. Cold shock proteins, specifically CIRBP, cold-inducible RNA-binding protein, and RBM3, RNA-binding motif protein 3. These proteins are produced in cells as an emergency response to rapid temperature reduction. They bind to messenger RNA strands that would otherwise be destabilized by the cold, preserving their structural integrity and maintaining the cell's ability to produce the proteins encoded in them, including the structural proteins of the dermal extracellular matrix. In a 2012 study published in the Journal of Investigative Dermatology, researchers examining cold shock protein activation in human skin fibroblasts documented that CIRBP activation directly suppressed EMP1 and EMP3, the collagen-severing matrix metalloproteinase enzymes that drive structural collagen loss in the aging dermis. The fibroblasts that had been cold shocked produced less of the enzymes that destroy collagen and more of the collagen itself, as measured by type 1 procollagen secretion. The cold was protecting the tissue's structural architecture. Not gradually, not subtly, measurably, in a controlled laboratory setting, using the same fibroblasts that determine whether the skin of a neck remains firm or begins to descend. For the AMA diver who enters cold Pacific water repeatedly across 30 years of working life, this cold shock protein activation has been occurring in her cervical skin fibroblasts hundreds of thousands of times. The cumulative effect of that repeated CIRBP and RBM3 activation, reduced IMP expression, maintained collagen synthesis, is the mechanism that explains, at least in part, why the neck of a 65-year-old AMA diver looks structurally different from the neck of a woman who has spent her adult life in thermally consistent environments. The cold was not damaging her skin. It was, through the cold shock protein response, maintaining the biology that keeps the skin structurally intact. The accessible version of this mechanism is a cold water rinse, not a full cold plunge, not a cryotherapy chamber. 30 seconds of cold water, as cold as the tap will run, applied to the neck and upper chest after the morning shower, every morning consistently. The temperature differential between shower water and cold tap water in the average household is sufficient to trigger cold shock protein gene expression in the dermal fibroblasts of the cervical skin. Research on brief cold water immersion and cold shock protein activation confirms that the stimulus does not require the sustained extreme cold of the AMA diving environment. It requires a meaningful temperature differential applied consistently over time. The aesthetic medicine industry has packaged this mechanism into ice bath subscriptions, cryotherapy facial treatments averaging $150 to $300 per session, and high-end cold therapy devices retailing for $200 to $400. The mechanism operates identically from a cold tap. The cost difference is measurable in dollars versus hundreds of dollars per session. And the cervical skin, the tissue most relevant for turkey neck prevention, is the tissue that benefits most from cold water exposure because it is the most exposed during any overhead or submerged position. The second mechanism is dietary, and it runs directly through a compound that the AMA divers have been consuming in high quantities for 2,000 years without any awareness of its molecular interaction with the fibroblasts of their cervical skin. Fucoidan, a sulfated polysaccharide found in the cell walls of brown seaweed, specifically wakame, kombu, mozuku, and hijiki, all of which are dietary staples in coastal Japanese communities, and all of which are consumed by AMA divers as part of the sea harvest they collect and eat. Fucoidan is not a compound that the mainstream skincare industry has ignored because it is ineffective. It has been studied in peer-reviewed research for its effects on dermal fibroblasts with consistent and striking results. A study published in the journal Marine Drugs documented Fucoidan's activation of fibroblast growth factor 2, FGF2, receptors on human skin fibroblasts. FGF2 is one of the most potent endogenous stimulators of fibroblast proliferation and collagen synthesis that the body produces. When FGF2 receptors are activated, whether by endogenous FGF2 or by a compound that engages the same receptor, the fibroblast responds by upregulating type 1 collagen gene expression, increasing cell division rate, and producing the extracellular matrix proteins that constitute the structural architecture of the dermis. The same study documented that Fucoidan at physiologically achievable dietary concentrations produced significant upregulation of type 1 procollagen synthesis in human skin fibroblasts in laboratory conditions. A second study, published in the International Journal of Biological Macromolecules, confirmed Fucoidan's inhibition of hyaluronidase, the enzyme that degrades hyaluronic acid in the dermal matrix, at concentrations relevant to dietary intake. The dietary consumption of Fucoidan-rich seaweed simultaneously stimulates the synthesis of new structural collagen through FGF2 receptor activation and protects existing hyaluronic acid from enzymatic degradation. Both effects are occurring continuously in the dermis of a woman who eats brown seaweed daily, as divers have done across their entire adult lives. The neck collagen that does not degrade in those women is being maintained partly by a dietary input that costs approximately $2 for a dried seaweed preparation sufficient for 2 to 3 weeks of daily consumption at the effective dose documented in the research. The skincare industry's response to Fucoidan research has been to extract and concentrate it into topical serums and supplements, retailing at $40 to $80 per month, positioning Fucoidan as a sophisticated marine-derived anti-aging active. These products are not ineffective. Fucoidan does penetrate the stratum corneum and does engage FGF2 receptors in the dermis at topically achievable concentrations in some formulations. But the dietary route, the route the divers have been using, delivers Fucoidan through the bloodstream to every fibroblast in every tissue simultaneously, including the cervical dermis, the platysmal fascia, and the retaining ligament connective tissue that anchors the cervical skin to the underlying tissue. The topical route addresses the surface. The dietary route addresses the entire structural biology of the neck from the inside. A 30-gram serving of dried wakame or kombu seaweed prepared as miso soup, a salad addition, or a rice accompaniment delivers a Fucoidan concentration consistent with the doses used in the published research. It also delivers iodine for thyroid function, magnesium for vascular tone, and fucoxanthin, a carotenoid with documented anti-inflammatory and protective effects. The diver eating seaweed every day is not supplementing. She is eating. And what she is eating has been maintaining the fibroblast biology of her cervical skin at the molecular level for decades. The third mechanism is the one that has no dietary analog and no topical equivalent, and that connects most directly to the specific practice of the diver rather than the broader Japanese coastal diet. The isobue, the exhale whistle. When an diver surfaces from a dive, the first action before the next breath is a specific controlled exhalation through pursed lips that produces the distinctive whistling sound by which diving has been identified in writing for 1,000 years. This exhale pattern is not cosmetic. It is physiological necessity. It empties the lungs of carbon dioxide rapidly and efficiently to prepare the respiratory system for the next breath hold. But the muscular mechanics of the isobue involve a specific sustained contraction of the orbicularis oris, the mentalis, the depressor anguli oris, and, critically, the platysma muscle of the anterior neck. The platysma is the thin, sheet-like muscle that runs from the clavicle upward through the anterior neck to insert into the skin of the lower face. It is the primary internal muscular scaffolding of the cervical skin. In the non-diving population, the platysma is minimally engaged during normal daily activity. It contracts during extreme facial expressions and strong neck movements, but spends the majority of each day in a low activation, low tone state. In a woman who performs the isobue breath hundreds of times per diving session, across hundreds of sessions per year, across decades of active diving, the platysma is being repeatedly and vigorously activated in a way that no other common daily activity replicates. Repeated muscle activation drives hypertrophy and maintained tone in the same way that any exercise drives adaptation in its target muscle. A platysma that has been contracting in the isobue pattern for 30 years is a fundamentally different structural entity than a platysma that has been largely inactive for 30 years. And the cervical skin that rests above a well-toned, maintained platysma, a skin that has structural muscular support beneath it, does not descend in the characteristic way of turkey neck, because the internal scaffold that turkey neck requires to be absent is present and functioning. Research published in Aesthetic Surgery Journal on platysmal exercise and cervical laxity in postmenopausal women confirmed that a structured program of platysmal muscle activation exercises over 12 weeks produced measurable improvements in cervical skin elevation and reduced submental laxity compared to controls. The muscle responds to activation. The skin above it responds to the muscle. The AMA diver has been activating her platysma twice per dive, hundreds of dives per season, for her entire working life. The accessible approximation of the isobue mechanism is not complicated. A sustained, controlled exhale through pursed lips, the same mechanical pattern as the isobue, regardless of whether it follows a dive, activates the platysma, the perioral depressor muscles, and the anterior neck musculature in the same pattern that the isobue produces. 30 to 40 repetitions each morning, performed during the cold water neck rinse, combines the cold shock protein stimulus of the cold water with the platysmal activation of the controlled exhale in the same 2-minute morning routine. This is not a clinical exercise prescription. It is the distillation of a 2,000-year-old occupational practice into a morning habit that produces the same mechanical stimuli through a different but biomechanically equivalent delivery mechanism. The aesthetic medicine industry addresses platysmal laxity with surgical platysmoplasty, a procedure that involves incising and repairing the platysmal bands, averaging $3,000 to $6,000, or with Botox injections into the platysmal bands that temporarily reduce banding while further reducing the muscle's activation and tone over time. Both interventions address the symptom of platysmal laxity after it has developed. The isobue mechanism prevents it by maintaining the muscle through consistent activation throughout adult life. Prevention and treatment are not the same clinical problem. The aesthetic industry specializes in treatment because treatment is billable. Prevention requires only a consistent behavioral pattern and produces no appointment revenue. Here is the 3-part morning protocol that incorporates all 3 mechanisms. Cold tap water applied to the neck and upper chest for 30 seconds immediately after the morning shower. The temperature differential triggers cold shock protein activation in cervical fibroblasts. 30 controlled exhales through pursed lips during the cold water application, each exhale activating the platysma and perioral musculature in the isobue pattern. And a daily dietary serving of brown seaweed, 30 grams of dried wakame or kombu, dissolved in warm miso broth, added to morning eggs, or consumed in any form that results in regular ingestion, delivering fucoidan for FGF2 receptor activation and hyaluronidase inhibition in the cervical dermis. Total cost, approximately $2 to $3 per week. Total time, 2 minutes per morning, plus the dietary preparation of a seaweed serving. Total biological effect across 6 months of consistent practice. Cold shock protein mediated EMP suppression and collagen synthesis maintenance in the cervical fibroblasts, FGF2 driven upregulation of dermal type 1 collagen through dietary fucoidan, and platysmal muscle tone maintenance through consistent isobue exhalation. These 3 mechanisms operate through 3 completely separate biological pathways. They compound rather than overlap. And their combined effect on the structural biology of the cervical skin is, across a working lifetime, what produces the neck of a 65-year-old AMA diver. The women of Toba did not design a cervical anti-aging protocol. They designed a way to harvest abalone. The cold water was the ocean they worked in. The seaweed was the crop they were collecting. The isobue was the breathing technique that kept them alive between dives. The cervical skin outcome was incidental, a biological consequence of a practice organized entirely around something else. And that incidental consequence is worth more than every neck lift, every radiofrequency tightening session, and every platysmal Botox injection performed in every aesthetic clinic in the world this year, measured by what it preserves in the tissue over time rather than what it temporarily repositions on the surface. Our complete anti-aging book covers every mechanism, cultural, biological, environmental, dietary, that the aesthetic industry has failed to convert into a product because it cannot be converted into one. Everything this channel investigates, organized in one resource. Link in the description and in the comments. If this opened something for you today, subscribe and share it with everyone you know who has been looking at their neck in the mirror and wondering what a surgeon could do for it. The Amadivers of Toba have been doing something for it since the 8th century. It costs nothing. It takes 2 minutes, and the Pacific Ocean has been confirming that it works for 2,000 years. The next vault opens soon. I'm Dr. Maylin. Thank you for listening to Dr. Maylin Health. There is a detail about the cold shock protein mechanism that the research has clarified, and that matters for understanding why the cervical skin specifically, rather than all body skin equally, shows the most pronounced benefit in Amadivers. Cold shock protein activation is site-specific, not systemic. When cold water contacts the skin, the cells at the site of contact experience the temperature differential and activate CIRBP and RBM3 locally. Adjacent cells that do not contact the cold water do not activate the same proteins at the same level. This means that cold water applied specifically to the neck activates cold shock protein specifically in cervical dermal fibroblasts, the cells that determine the structural integrity of the tissue where turkey neck originates. Cold water applied to the face activates them in facial fibroblasts. Cold water applied to the hands activates them in hand skin fibroblasts. The anatomical specificity of the cold shock response is both the explanation for why Amadivers show particularly pronounced cervical benefit. Their necks and upper chests are the surfaces most directly exposed during the head-up breathing position between dives, and the practical instruction for anyone applying this mechanism at home. The cold water should go on the neck. Specifically, consistently, the 30-second application to the anterior and lateral cervical surface after a morning shower is not interchangeable with a cold face splash. The cervical dermis is the target tissue. The cold water is the targeted delivery mechanism. And the 30 seconds of discomfort it takes every morning is a very precise trade for the 2,000-year outcome that the Amadivers of Toba have been demonstrating on the same stretch of Pacific coastline since the tradition was first recorded in writing. The Ama tradition is declining. The younger generation of women in Toba is choosing different careers. The number of active divers has fallen from approximately 40,000 in the mid-20th century to 2,000 today. As that tradition disappears, so does the living demonstration of what 2,000 years of cold water exposure, seaweed consumption, and controlled cervical muscular engagement produce in the tissue of the human neck. What remains is the research, the cold shock protein studies, the Fucoidan fibroblast data, the platysmal activation research, and a cold water tap that anyone can turn on every morning for 30 seconds before the rest of the day begins.